I'm going to tell you about some work that my team and I are doing in Australia at the University of Queensland on a technology designed to tackle those 4 problems. And that technology is called the nanopatch. Now, this is a specimen of the nanopatch. To the naked eye, it just looks like a square, smaller than a postage stamp. But under a microscope, what you see is thousands of tiny projections that are invisible to the human eye. And there's about 4,000 projections on this particular square compared to the needle. And I've designed those projections to serve a key role, which is to work with the skin's immune system. And so that's a very important function tied in with the nanopatch. Now, we make the nanopatch with a technique called deep reactive ion etching. And this particular technique is one that's been borrowed from the semiconductor industry and therefore is low cost and can be rolled out in large numbers. Now, we dry coat vaccines to the projections of the nanopatch and apply it to the skin. Now, the simplest form of application is using our finger, but our finger has some limitations. So we've devised an applicator. And it's a very simple device. You could call it a sophisticated finger. It's a spring-operated device. What we do is when we apply the nanopatch to the skin, as so, immediately a few things happen. So firstly, the projections on the nanopatch breach through the tough outer layer, and the vaccine is very quickly released, within less than a minute, in fact. Then we can take the nanopatch off and discard it. And indeed, we can make a reuse of the applicator itself.